Okay, let's have a go at the second derivative using a quartic function. Alright, so we have negative x to the power 4 plus 20x squared take away 64. Now, there's some things we already know about a quartic function. We know that it is W shape or M shape if it's negative, like so, okay? And so just from the structure of a negative quartic function, we know that it's concave down in the left, then it's concave up in the middle, and then it's concave down again on the right-hand side. Okay, and that's going to be really helpful to us. So what do you think is going to happen then? Between the down and the up, there's going to have to be a point of inflection between them. And likewise, between the up and the down, there's another point of inflection just there. So, by doing the algebra, we're going to find the location of the point of inflections, as well as the regions for which the concavity changes. Here we go. The first derivative is negative 4x cubed plus 40x, and then I lose the constant. And the second derivative is negative 12x squared plus 40. So let's solve the point of inflections first. I have negative 12x squared plus 40, make it equal to 0. Now, we have a quadratic, an x to the power 2. Would that make sense? Well, I'm anticipating up to 2 answers, so yeah, that actually makes a lot of sense. Alright, I have even numbers, so I could divide by 4 in this case, or even negative 4, and I'll get 3x squared take away 10 is equal to 0. Move the 10 across and divide by 3, and then I can square root both answers. So there's one answer. Where is my second answer going to be? When you take a square root, don't forget that there's always a negative answer with it. So that's where my point of inflections are. The negative root 10 on 3 must be the one on the left. And the positive must be the one on the right. Okay? So that means then that all the values to the left are the second derivative will be negative. All the values in the middle, the second derivative should be positive. And all the values to the right of root 10 on 3, all the values of the second derivative should be negative again. All right, let's demonstrate that. Pick a value to the left of negative root 10 on 3. I'm going to pick negative 5, and we'll substitute it into the second derivative. We have negative 12, negative 5 squared plus 40 is equal to negative 12 times 25. Well, that's a very large number. And when we add 40, we are obviously going to still get a negative number. It's less than 0, therefore it's concave down. And that makes sense. Then we'll do the same for the second derivative, substituting a value between these two. Let's say 0. And we get negative 12 times 0 squared plus 40. That's going to come out to be 40, which is greater than 0. Therefore, it's concave up. And that confirms our diagram. All right, I need to make a bit of room now. Finally, let's choose a value to the right of the positive of root 10 on 3, like the number 5. And we have negative 12 times 5 squared plus 40, and that's going to be equal to negative 12 times 25. Again, a very large negative number. When we add 40, it's still going to come out to be less than 0, and therefore this is going to be concave down. Okay, so let's put all of this into a nice tidy table. Our x values go in first, then we're going to discuss the second derivative, And then we'll discuss the concavity, and I'll just put CONC for short. Okay, so we used values to the left of negative root 10 on 3. Then we found at negative root 10 on 3. And then we found a value 0. And then we found the positive root 10 on 3. And then we found a value 5. Okay. This is a bit of a summary. To the left, which was this one here, we found that it was less than 0 and it was concave down. At negative root 10 on 3, we found that it was the second derivative was equal to 0 and we had a point of inflection. Then at x equals 0, we found that it was greater than 0 and it was concave up. At root 10 on 3, we had the second derivative equal to 0 and a point of inflection. And when x was 5, we found that the second derivative was less than 0 and we had a concave down again. Now, just to be consistent, I really should say that these values are greater than root 10 on 3. And that's a little tidy table you should put into your exam to summarize what's happening. And there you go. Good luck with those questions.